Welcome to Pure Mathematics 1, Chapter 6, Integration, Topic, Area as the limit of a sum. So here, let's say I have a curve, like this one. Here. This one. The curve is y equal to x squared plus 2. Okay. So now I want to find this area. Here's my 1. Here's the x-axis and here's the y-axis. And I have 4 in here. So now I want to find this area in here. Because I don't know how to find this one. So now I will estimate it first. I will draw the section out here. Here in the section. Okay. So I will estimate by drawing a lot of rectangle. Like this one. Here. And here. And here. This one. This one. Here. Because I use rectangle, so I can find the area of these rectangle, and I have, let's say I have all of the values in here equal to each other, 1 to 4, and I have 1, 2, 3, 4, 5, 6, 7. So each of them will be 3/7 in length. So it's easier for me to calculate them here. But now I am underestimating the area because I have some place in here. You can see it here. The hole, I cannot fit into it, right? So my estimation is underestimated. Here, this one. So this one is underestimation, but I have another way to estimate this one is overestimation. I can illustrate it like this one here, here, here. They're quite the same, so I would use this one as my example, and this one, you know, it exists, but now I will work on this one. In this case, I draw 7 strips of this one. It's a rectangular box. I call it 1 strip. But now, if I have n strips, you can see that if I increase the number of strips, it will go closer to the exact number because it will be more accurate, and the areas of these shaded area will be smaller. And if my n, the number of strips, go to infinity, I will have the exact number of the areas. And now I will give you the general form to find the area under the curve between the curve and the x-axis. It will be like this one. Here, you have A and B, and A is your upper limit, and B is your lower limit. In this case, A equal to 4. This one is the upper limit, and B is the lower limit. So please remember that always the bigger numbers will be up here, and the smaller number will be down here. And then I have my equation y and dx. You can see it look like an S. It look like an S because it is the sum. It means that we are taking the sum of all rectangular box in here, and this one is going to infinity. So we have the equation here. So now substituting into this case, we have at the 4 and 1 here equal to x squared plus 2 dx, and now it will be equal to, you put a square bracket in here, and now you rewrite your limit out here, 4 and 1. Okay, remember this rule, and you integrate the one inside here. So you know the rule for integration, x cubed over 3 plus 2x. And now you want to find the area, so you substitute the value into here. You substitute 4 in here, you have 4 cubed over 3 plus 2 multiplied by 4. And you take this one, you minus, and the one that you substitute 1 into here, 1 cubed over 3 plus 2 multiplied by 1. This one will be equal to 27. So the area of this one here, the shaded area here, is 27. And now I have another example for you guys. Let's say I have the graph y equal to 2x squared plus square root of x. And now I want to find the areas of this one from x equal to 4 to x equal to 9. The area of the curve from 4 to 9. So first I will have to convert this one into the standard form, x squared plus x to the power 1 over 2. So in order to find the area of that one, we use the formula 9 here's 4. 9 is my upper limit and 4 is my lower limit. And then I will put y in here, which is 2x squared plus x to the power 1 over 2 dx. This one equal to, we give a square bracket here, and then we integrate this one, which is 2x cubed over 3 plus with x to the power 3 over 2 over 3 over 2. Because 1 over 2 plus 1 is 3 over 2. Here's 9 and here's 4. So n equal to 2x cubed over 3 plus 2x to the power of 3 over 2 over 3. Because when you divide it by 3 over 2, it means that you are multiplied by 2 over 3. You reverse it and multiply with it. Here's 9 and 4. You can see that 2 over 3 is a common factor, so we would take it out because it will not affect the result. Here's x cubed plus x to the power 3 over 2, 9 and 4. And now I will substitute into here. It is a constant, so I keep it there. 9 cubed plus 9 to the power of 3 over 2 minus 4 cubed plus 4 to the power of 3 over 2. This one will be equal to 2 over 3 multiplied by 756 minus 72 equal to 2 over 3 multiplied by 684 equal to 456. So the area of this curve from x equal to 4 to x equal to 9 is 456. The symbol here, we call it the integral. So we have two types of integral. The first type is definite integral. In the integral that involve the limit a and b, and you have the upper limit and you have the lower limit, like we did before with the areas, and this one can be evaluated to give an exact number. Let's say I have here 9 and 1. I have the x here, dx. So this one will be equal to x squared over 2, 9, 1, and then I substitute in there. I have 81 over 2 minus 1 over 2 equal to 40. So the one that involves the upper limit and the lower limit will be called a definite integral, and it would give an exact number. And the second one is called an indefinite integral. For this one, we don't have any limit in here. We just have the equation. Like I have the equation x cubed plus 4x squared minus 3x plus 7 dx. So for this one, when I integrate it, I will have something like this. I have x to the power 4 over 4 plus 4x cubed over 3 minus 3x squared over 2 plus 7x. And here I have to add the c, which is called the arbitrary constant. You know that integration is the reverse process of differentiation. When you differentiate x squared, you have y equal to x squared. You have dy over dx equal to 2x, right? But when you differentiate x squared plus 9, it will give the same result, which is 2x. So C here is an arbitrary constant that can receive any value depending on the equation. So when you see an indefinite integral, you must add a C at the end.